So in today's lecture, we shall be discussing about a mathematical tool that is used for solving linear ordinary differential equation. Why we require this tool? Because we have already seen that in study of dynamic systems, the behavior of the dynamic system is characterized by linear ordinary differential equations, because we have only considered linear time invariant dynamic systems, and we'll mainly focus on the study of dynamics of linear time invariant systems. So to obtain the dynamic response of linear time invariant system, our objective was to solve a differential equation that describes the dynamic performance of a system. Now there are many methods of solving the differential equation. The easiest way is to integrate the differential equation to obtain the final solution. But there are certain problems in using this integration method. Now there are multiple steps required to solve the differential equation using integration method. To facilitate this solution of differential equation, a technique that is normally used is, or a mathematical tool that is normally used is called a Laplace transform method. তো তোমরা জানো তো Laplace transform মেথডটা সম্বন্ধে? What is Laplace transform? Anybody?
Yes, sir.
Okay. So when in which course have you studied this Laplace transform? Mathematics or any other course?
Sir, second semester
circuit
maths
theory.
ছিল আর সার্কিট থিওরিতেও ছিল।
Bas. Very good. Very good. So what are the benefits of Laplace transform or application of Laplace transform?
ডিফারেনশিয়াল ইকুয়েশন গুলো আমরা অ্যালজেব্রিক ইকুয়েশনের মতন করে ট্রিট করতে পারি,
রাইট? তাহলে সুবিধাটা কি হবে?
আর স্যার ইনিশিয়াল কন্ডিশন গুলো একসঙ্গে ইনক্লুডেড হয়ে যায়।
ওকে, ভেরি গুড। আচ্ছা, তা কি করে সলভ করো ল্যাপ্লাস ট্রান্সফর্ম ডোমেনে? তোমরা কি করে কোনো সিস্টেমের ইকুয়েশন সলভ করো কিংবা ডিফারেনশিয়াল ইকুয়েশন সলভ করো?
স্যার লেফট হ্যান্ড সাইড আর রাইট হ্যান্ড সাইড দুদিকেই ল্যাপ্লাস ট্রান্সফর্ম না হয়, তারপর সলভ করা হয়।
তাহলে কি হয়? ডিফারেনশিয়াল বা ইন্টিগ্রাল ডিফারেনশিয়াল ইকুয়েশনটা it gets converted to algebraic equation. Then you manipulate the particular equation to yield the relation with respect to the solution that you desire. Right? Say if you want to solve for xt, then you should have expression for xs, right, in the left hand, and in the right hand you will have the expansion of xs, right, or the representation of xs in terms of s domain parameters, right? Now you should always keep in mind that when you are studying the dynamic response of a system, there is a time domain phenomena. But to facilitate the solution, we are converting this time domain phenomena to a frequency domain phenomena that is given a signal ft using Laplace transform. We are converting it to fs, which is a frequency domain phenomena. So whatever you are getting as a solution of this differential equation using Laplace transform, you again need to convert back using inverse Laplace transform to obtain the actual response, because this is what you desire, the actual time response, ft or xt, anything like that. So there are two operations. Given a differential equation, you first have to obtain the Laplace transform. For that, standard methods, the standard formulas are there. And next, you solve for fs. Then you take inverse Laplace transform of that solution, so that the final form of the solution, that is ft, is yielded. So I should not devote much of the time on Laplace transform. I think you are much more conversant with the Laplace transform. Okay, in Laplace transform, what have you studied? The Laplace transform of different functions, different signals. Have you studied those? Like
yes,
step
sir.
signal, ramp
yes,
signal, এগুলো পড়েছো তো? And some of the properties of Laplace transform, I'll just point out some of the important properties that might be necessary. Since I'm only hearing from one or two of you, I'm not being able to communicate to all of you. I don't know about others. Just to keep everything in check, what I'll do, I'll give you a brief introduction to some of the important formulae. Just a second, I'm getting a call. One second. So I'll just briefly write down some formulae that may be required. So the important formula that you should remember for this, the formula will be S of Fs minus F0. This is one very important formula that you should remember, because that will be required to in solving a differential equation. In the first step, you have to convert that to a Laplace domain. So this is a formula that is very important. In general, if it is a first order derivative, in general, you can write Laplace of nth order derivative of ft can be expressed as s to the power n of fs minus s to the power n minus 1 f0 minus s to the power n minus 2 f of 1 0, and this will continue. Someone is trying to get in, and this will continue, and at the end of the day, you'll get minus f of n minus 1 0. See, this is s to the power n fs minus s to the power n minus 1 f0, the initial condition of f0. This is s to the power n minus 2 f10. That means first derivative of ft when the initial condition is set to 0. So similarly, this will be the nth derivative of ft and its initial condition at least as t equal to 0. So this is the formula in general. So for n equal to 2, it will be s square fs minus sf0 minus f dash 0, or the first derivative of ft dft dt at t equal to 0. I think you remember this formula, right? This is one important formula. Another important formula that you should remember is that of integration. Okay, if you have integration, because in differential equation we also find integrals, so it is sometimes called integral differential equation. Now, what is the formula for integration? Say suppose for 0 to t f tau t tau, if you take Laplace of this, what you'll get?
Fs by s.
Right. So these are the two very important formula that you should always keep in mind. Now, in studying the properties of a system, there are two other formulas, that is shift in time. If you have a signal that is shifted in time, then what will be the effect? To study that, you need to have this formula, that is Laplace of f t minus capital T u of. Can anyone tell me what will be this Laplace transform?
E to the power
To the power
minus
minus
ts into
f of
fs.
s.
Right. This is something very important. I was trying to find out the value of f of Laplace transform of f of t minus capital T. Okay. But why I have introduced this u of t minus capital T? Any idea? I could have simply written f of t minus capital T. So why I have used this term u of t minus capital T? Any idea?
যাতে
স্যার f of 0 টা
f of-
0 হয়ে যাবে।
সেটা না তোমাকে দেখো, in Laplace transform the formula for Laplace transform is like one sided. We'll be always considering the one sided Laplace transform.
মানে স্যার যে ক্যাপিটাল টি থেকে ইনফাইনাইট
Yes, so just shifting. This is 0 to infinity, but this is ft minus capital T, and we always assume that ft equal to 0 for t less than 0. So to obviously then, if you have this f t minus capital T, that is shifted in time domain, so it should be 0 for t less than capital T. To ensure that, this limit should also be changed through capital T to infinity, and that can be ensured by multiplying this by unit step function. This ut is a unit step function which has a value 0 for t less than capital T. So this will ensure that this integration takes place only considering the function t of t minus capital T. That is, it starts from t equal to capital T. So to ensure that this multiplication is to be ascertained, right? Now, obviously, if you are conversant with this Laplace transform, you will always start with capital T. That's fine. But in case you forget that, then you have to use this formula. Then what will happen? Automatically, due to this function, the limit will change over to t equal to this capital T to infinity. Right? Understood? So this is just to emphasize the fact that it is a one-sided Laplace transform, and it is based on the concept that this ft is less than 0. Is 0 for t less than 0. So it is only after t equal to 0, it has some value. And before that, we are not considering the value of ft. This is one-sided Laplace transform, right? Just to emphasize that fact.
স্যার
This follow.
স্যার এখানে এই যে মানে ft ইকুয়ালস টু 0 স্মল টি লেস দ্যান 0 হলে এটা যদি ডিফাইন করা হয় তাহলে তো আর ইউ অফ স্মল টি মাইনাস ক্যাপিটাল টি যেটা আছে ওই টার্মটা দরকার হয় না, মানে
হ্যাঁ, যদি ডিফাইন করা হয়, right, this is the definition. But to make sure that this condition is always satisfied, তুমি যদি simply এটা করো, you may have forgotten
স্যার মাইনাস ক্যাপিটাল টি আসে নিচে স্যার। স্যার মানে ইন্টিগ্রেশন লিমিটে তাহলে মানে ম্যানিপুলেশন করলে একটা মাইনাস ক্যাপিটাল টি আসে।
ওকে, yes, হ্যাঁ, তুমি যদি এখানে t মাইনাস ক্যাপিটাল টি কে ডেল্টা ধরে নাও, তখন t টু ইনফিনিটি হয়ে যাবে, রাইট, সেটা হয়ে যায়। This is just to emphasize the fact that in this case, this statement indicates that in this case, the integration will start from capital T to infinity. So you don't have to look into the integration itself. This is because the ft was supposed like this, the function. Now you remove it, moving it in this direction by t. So the nature will remain same, just it will be shifted by capital T. Okay? And this will be important in finding out whether a system is time invariant or not. Okay, in that case, we have to use this formula. Right? Okay, you're right, you're absolutely right. That can be formulated. But this is a custom. This is a custom to represent this in this fashion. So that you always, even if you miss out this idea, this always is emphasized by this fact. Okay? That a function will be non-zero only after t equal to capital T or t equal to 0 or t minus t equal to 0. The operand should be 0. Only after that it will become a non-zero function. Similarly, okay, shall I proceed?
Yes.
Okay. Similarly, if we have, on the other hand, Laplace, I don't think it will be very much necessary, but if you have something like this, it is minus alpha t ft, what will be that?
f of s plus a.
S plus a.
Alpha, right. This is a usual time shift. We normally face this time shift due to the time delays involved in the system. So this formula will be always very helpful. Now, going on to the next step, I think you know this formula, the very important theorems.
Yes, sir.
So what is that initial value theorem?
Sir, f of 0 equals to limit s tends to infinity s f s.
No, that is a statement. What is the function or the purpose of initial value theorem? It will give you the value of function ft at
Time equals
t
to
equal
0.
to 0 plus. Do you understand what is t equal to 0 and t equal to 0 plus?
Yes, sir.
What is the difference between t equal to 0 and t equal to 0 plus?
Sir, t equals to 0 plus is the next instant. That means the immediate instant after t equals to 0.
Actually, if you consider some excitation at t equal to 0, or if you want to just have an idea about the dynamics just after t equal to 0, or normally t equal to 0 is taken as a reference point where your step function generates its response. It gives you an impulse, not impulse, a step input at t equal to 0. Then immediately after that point, what is the state of the system? That is called t equal to 0 plus. T equal to 0 means it may seem that the system may remain at t equal to 0 for indefinite time. Why? Until or unless you excite the system, there is no need to calculate the dynamics. So system dynamics will only be calculated once you excite the system by any input. Once you excite the system by any input, that particular time will be considered as t equal to 0 or your reference time, and the time immediately after that will indicate the response. That is, response has been initiated. If you just write t equal to 0, it will means it is either waiting for the response input to come, right, or input has just occurred. To emphasize the fact that it is the time just after the system is excited that plus sign is given. Understood? Suppose this object is lying in a plane, it will remain there. Now only when, if you put a disturbance, if you push the object, then only it will start moving. So t equal to 0 will be at the time when you just came in contact with the object and started pushing it. And before that, you can assume that it was at t equal to 0, because at any moment you could have started it. So reference point was defined at any moment, but it is only initiated at t equal to 0 plus. That is, it started moving. You do not know when the input will come. So your reference point is always at ready, but it is not initiated. It is initiated only at t equal to 0 plus. That is why t equal to 0 plus is used. But in some of the literatures or some of the books, they normally don't find or don't reiterate this fact, t equal to 0 plus. But in initial value theorem, we should always remember that it is t equal to 0 plus, not t equal to 0, right? ব্যাপারটা বোঝা গেল তো কি হচ্ছে? কনফিউশন দেখলে বলো। এটা তো ইনিশিয়াল ভ্যালু থিওরেম। এটা কি করে প্রুফ করা হয় জানো? নো how this theorem is achieved? Have you gone through the proof of this theorem?
Yes, sir.
জানো, তাহলে পড়ানোর দরকার নেই তো আর। আচ্ছা, ইনিশিয়াল ভ্যালু থিওরেম কোনো কন্ডিশন আছে? এটা সবসময় ট্রু?
সবসময়
ট্রু।
বলো কন্ডিশনটা কি?
ফার্স্ট ডেরিভেটিভ স্টেবল সিস্টেমের জন্য অ্যাপ্লিকেবল, একটা নন স্টেবল সিস্টেম আনস্টেবল সিস্টেমের জন্য অ্যাপ্লিকেবল নয়।
না
স্যার
এটা
ওটা
initial
বোধহয়
value
না
theorem এর জন্য
ফাইনাল
বলতে
ভ্যালু
পারবো। হ্যাঁ, ওটা
থিওরেম।
ফাইনাল ভ্যালু
ওটা
থিওরেমের
স্যার
জন্য
ফাইনাল
হয়।
ভ্যালু থিওরেমের জন্য।
তাহলে এটা কি
বোধহয় সব
condition
ক্ষেত্রে
আছে?
অ্যাপ্লিকেবল মনে হয়।
না, এটা সব ক্ষেত্রে অ্যাপ্লিকেবল বলতে পারো না। একটা কন্ডিশন হচ্ছে ft and dft dt should be Laplace transformable. সরি, এগুলো হতে হবে ল্যাপ্লাস ট্রান্সফর্মেবল। মানে যদি ল্যাপ্লাস ট্রান্সফর্ম যদি না করতে পারো তাহলে কিন্তু এটা হবে না, অবভিয়াসলি। নাহলে তুমি তো লিখতেই পারবে না। না, এই যে এটা দেখো, এটা থেকে আসছে, দিস ল্যাপ্লাস ট্রান্সফর্ম অফ dft dt, right? So this should be Laplace transformable, and most importantly, this limit should exist. If this limit doesn't exist, then the initial value theorem will be not valid, right? So these are the two conditions. This to Laplace should be Laplace transformable, and this limit should exist. And next, let us consider the more important theorem, final. So what is the final value theorem? What is the implication or application of final value theorem?
Sir, at
বলো, final value
infinity,
theorem?
what is the ft? That value is calculated.
ওকে, এটা তুমি এরকম ডিসক্রিট ভাবে বললে, আরেকটু যদি গুছিয়ে বলতে পারো।
স্যার স্টেডি স্টেট ভ্যালু দেয়।
Right. It is related to the steady state behavior. Okay. Steady state behavior. Because at the end of the day, we are very much interested in finding out the steady state performance of a system, right? It may have different transient or different types of natures of response to reach a final value, but we are more concerned about what is the final value that it reaches. First of all, it should reach a final value. If it doesn't reach a final value, that it means it's an unstable system. Then you have to stabilize that. If it reaches a final value, we have to find out what is the final value that it reaches. And that final value is normally given in terms of final value theorem. So normally you can write the final value theorem as this, right? So t tends to infinity ft equal to limit s tends to 0 sfs. So what it does, it relates the behavior of ft as t tends to infinity to the behavior of sfs in the neighborhood of s tends to 0. Okay, that's the second. I'm getting another call. 1 second, huh? Okay, so again, coming back to this final value theorem, it is relating the final value of ft as t tends to infinity to the value of sfs in the neighborhood of the point s equal to 0 in the s domain. Okay, so again, there will be certain conditions that need to be satisfied, a condition that need to be verified before you apply the final value theorem. What are these conditions? Obviously, this will be redundant. ft and dft dt should be Laplace transformable. And then the final condition or most important condition will be that this limit should exist, right? Because if this limit doesn't exist, that what does that mean? That means the system is not settling down to a particular value, or in other words, the system is either having a value which is exponentially increasing with time, there is a case of a unstable system, or it is oscillating about a band of values, or oscillating between a band of values, say v max, v minus, something like this. So there will be two cases where this final value theorem will not be applicable. So I think you have the concept of poles of a system or roots of a characteristics equation. So this theorem will only be valid if
Yes, sir.
the roots of the characteristics equation or poles of the system lie in the open left half plane. Open left half plane. Okay, so what does the open mean? Open left half plane mean? Left half plane is okay. Left half S plane. Obviously, this is S plane. Left half S plane is fine. It is to the left of the imaginary axis. Then what does this open left half plane mean?
Sorry, excluding the imaginary axis.
Right. What happens if the poles are on imaginary axis?
So the system may be marginally stable or maybe unstable.
No, it will be marginally stable, and the
So
result
it may
will
be
be
unstable also if the roots are multiple roots are on the
right.
imaginary
If
axis.
multiple roots are there, right. If there are two or more roots, it will be unstable. Okay, and if they are complex conjugate, then it will be a
Marginally
sinusoidally
stable.
varying. It will give you sinusoidally varying output with oscillatory output. So, in both the cases, this final value theorem will not be applicable. So, it will only be applicable if the roots of the characteristics equation or the poles of the system lie in a left half plane, right? So, that's fine. Let us now proceed. I guess you'll just understand the initial value theorem and final value theorem, and you also practice your skills of deriving the initial value theorem and final value theorem. Okay, I think you know how to derive the initial value theorem and final value theorem. All of you know how to derive initial value theorem and final value theorem. If any one of you do not know, please give me a feedback, or otherwise I shall continue. সবাই জানো তো কি করে বের করতে হয় ইনিশিয়াল ভ্যালু থিওরেম ফাইনাল ভ্যালু থিওরেম আর প্রুফটা? ঠিক আছে, ধরে নেবো তাহলে জানো, এখন চুপচাপ আছো, that's fine. Okay, I'll just conclude this thing with a final form of, okay, I don't think this definition is required as of now, but this will be required in the next session when we will be dealing with transfer function. but still we are dealing, since we are dealing with Laplace transform, this is very important. Suppose ft is given as multiplication of two time varying function f2t, and this can be written as convolution integration d tau. Now, what about the Laplace transform of ft?
F1s into F2s.
You know these things? Very good. It will be F1s, F2s. Now, this will be very important while deriving the transfer function or the time response of a system when subjected to different forms of input. So this is the convolution integral and the corresponding Laplace transform. Okay, so since we are very much conversant with this Laplace transform, although I'm making this conclusion and arriving at this conclusion based on the feedback of only a few, and since others are not responding in a negative manner, in a negative way, I shall consider that they've already understood this tricks with Laplace transform, and basic things of Laplace transform are very much clear to all of you, right? So what we'll do, we'll discuss about the methods of solution of ordinary differential equation using Laplace transform method. Okay, so to start, I shall check how much conversant you are with this method by giving a problem. So I guess all of you are having a notebook or anything with you so that you can solve a particular equation that I'm giving now. Just try and solve this differential equation using Laplace transform method and tell me the answer. Okay, so is this enough or do you need any more information?
Sir, the
Sir,
initial
initial
conditions.
Initial condition that one.
So x0 equal to a. Fine. Anything else?
X dash 0 value that one.
Enough? Now you solve it. Okay, you solve it and tell me what will be the solution. So simultaneously, I'll also try and solve it, taking Laplace transform. What you'll get, s square xs minus s x0 minus x dash 0 plus 3 into sxs minus x0 0. So taking into account the initial conditions, where we get the xs to be as plus 3a plus b now to get the partial fraction is What will be this? পার্শিয়াল ফ্র্যাকশনটা করা যাচ্ছে? দেখো এরকম আসছে নাকি? তো পেয়েছো আনসারটা?
স্যার 2a plus b e to the power minus t
একটা
ut
2 প্লাস একটা a প্লাস
হ্যাঁ এরকম
Manager problem. ঠিক আছে, ঠিক আছে। You can always write ut or you can just simply define t greater than equal to 0 for t greater than equal to 0, right? So, okay, fine. Now, let us indulge into some interesting situations that you may face while solving our differential equation, right? So, shall I move on from this page? I think you have all gone, have got the result now. You can always take a screenshot, okay? You can always take a screenshot. Just take a screenshot if you want for a reference. Okay, now moving on, huh? Now we'll talk about different situations that we normally face while solving this differential equation using Laplace transform method. Because while deriving the expression for inverse Laplace transform, we need to express them in terms of partial fraction expansion, right? That is in terms of f1s, f2s, f3s, where this f1s, f2s, f3s should have some common form that can be easily converted to t domain by using standard rules of inverse Laplace transform. In this regard, there may be different cases that may arise. Case number 1 is the system equation has distinct poles only. The poles are all distinct. That means your I should not write GS right here. The final polynomial say of xs is such that there is a ratio of two polynomials and it is represented as k divided by so this system has m number of zeros and n number of poles, right? So what are the situations that may occur between the relation between n and m? If n is greater than m, what is this system called? This will be, this excess or this system will be called a strictly proper system. This number of poles is more than number of zeros. If n equal to m, then you call it a biproper system. If n less than m, there are more number of zeros than poles, then called a improper system. Now, each of these in strictly proper, biproper, and improper system have their individual characteristics. Okay, for strictly proper system, it's very easy to obtain the factors in a partial fraction form. For biproper system, it's still easy, but for improper systems, it involves a few extra steps. Okay, so once this is given, what will be your next step? You have to obtain xs in the form, say a1 s plus p1 plus a2 s plus p2. How much it will go up to n s plus pn. So what you need to calculate this a1, a2, n. What are these? These are the residues of xs at that particular pole. S equal to p1, s equal to p2, s equal to pn. So how this ak can be calculated?
S plus
Any of
pk
the-
into xs.
Yes. Then
S equals to minus pk.
right, exactly. Right? There's a very simple formula you can use here. You calculate the values of a1, a2 up to n. And once you get that, then your final solution will be in the form ak e to the power minus pk into t, right? Corresponding to this, any of these factors. So each of these factors will yield something like this. So it's very trivial, and if already very much conversant with this sort of computations, right? So let's consider an example that you might face in a situation where it may seem that it is not that simple. See, let us consider an improper transfer function, right? Given an improper transfer function, that is number of zeros is more than number of poles, then what would be the solution? Improper transfer function or improper ratio of polynomials. I should not be using this term transfer function as of now, but I guess all of you know what is a transfer function. What is the transfer function definition? Circuit theory?
Yes, sir.
Yes, sir.
Then obtain xt. Can you solve this? How to solve this? পারবে করতে এটা? So what is the first step? See, there are 3 zeros and 2 poles. The first step will be then
ডিনোমিনেটর দিয়ে ভাগ করতে হবে।
right. So what will be this? Say multiply by s cube plus 3s square plus 2s. So it is the 2s square plus 7s plus 7. So plus 2 2s square plus 6s plus 4. That will be finally s plus 3. So what will be this? This can be represented as, just a second. How it can be represented then? It can be represented as s plus 2 plus s plus 3 divided by s plus 1 into s plus 2. Right? So this is very easy to obtain the inverse Laplace of. Then what about the first two terms? Is there? What will be the Laplace transform of the first two terms? S. What is the Laplace transform of S? Or how inverse Laplace? Sorry, inverse Laplace of S. So your xt, what will be xt corresponding to this? Okay, what will be the inverse Laplace of 2?
2 delta t
Yeah, right. What is delta t?
impulse function.
Yeah, impulse function. It's impulse function. And what about this? S? Isn't it?
Yes, sir. Yes, sir.
This is the first part. And the second part is very trivial. You can simply use that previous formula to see the second part will yield something like two e to the power of minus t minus e to the power of minus 2t. This is all defined for t greater than equal to 0. So this is how, given an improper transfer function, you can obtain the corresponding inverse Laplace transform, or in a situation, I should not say again the term transfer function, in a situation where you get the numerator to have an order more than the denominator, then you can have this sort of expressions, right? So there is an impulse function and a derivative of impulse function. So as you can see, this is not a very pleasant scenario, but still it can be solved. Okay, the solution is not a very pleasant one. So next case that we may face is simple complex conjugate poles. That is a system having complex conjugate poles of the nature one second, I'm getting another call. Just a second. Okay, so sorry. So simple complex poles that we should consider, and that means the poles are given in the form S equal to in this form, the poles are given. So if we have your excess in the form, say simple k1 s plus P1 plus K2 S plus P2, where this P1 and P2 are this minus sigma plus j omega, minus sigma minus j omega. Then what you can do, you can follow the simple rule and calculate your K1 as S plus sigma minus j omega xs at S equal to minus sigma plus j omega, and K2 as S plus sigma j omega xs calculated at S minus sigma minus j omega. So this is standard as following the same principle in the previous case. And this is, I think, what you do normally, right? Or else? এভাবে তোমরা সলভ করো, অন্য কোনো মেথড ইউজ করো?
না স্যার, এভাবেই করি।
Okay. Now let us check. দেখো, if I can help you in solving this sort of equations having complex conjugate poles, there are other methods. Suppose your xs is given as 2s plus 12 divided by s square plus 2s plus 5. Okay, now find xt. So in this case, you can obviously factor this s square plus 2s plus 5 in the form s plus 1 plus j2 into s plus 1 minus j2 form and obtain k1, k2. But I will recommend that you do not do that. What you do, you rather represent it as s plus 1 whole square plus 2 square. Then what will happen? Your xs will be 2s plus 12 divided by s plus 1 whole square plus 2 square. And sorry, 2 square. Now this numerator again can now be represented as 10 plus 2 into s plus 1, see, divided by s plus 1 whole square plus 2 square. So after slight modification, what you'll get, 5 into 2 upon s plus 1 whole square plus 2 square plus 2 into s plus 1 divided by s plus 1 whole square plus 2 square. Now, do you see any particular form in these two factors?
Yes, sir.
Sin theta cos theta.
What are
Shifted
these?
sinusoidal.
Shifted or damped sinusoidals. Okay, so what will be xt then?
Five
Shifting
e
is
to
by
the
E to the
power
power minus t
minus
sin 2t.
হ্যাঁ, plus 2 e to the power minus t cos 2t.
So is this simpler, or that particular k1 k2 method is simpler in this case? It's up to you. Obviously up to you. Right? Just by looking at that, what we have done, instead of putting it s plus 1 plus j2 s plus 1 minus j2, we have converted the equation into damped cosine and damped sine functions in terms of partial fraction expression, so that we can directly write down the expression including that delay terms, it is the minus t terms. If I had gone for that s plus 1 plus j2 s plus 1 minus j2, it could have been a bit lengthy one, right? Now in this case, the relative order of the system was 1, that is, numerator was 2, 1 and denominator was 2. So the difference of order between them was 1. The situation will be slightly different if you have a system where this difference in order is more than 1, say 2 or 3. So let us consider another example for the sake of understanding. Suppose you have equation which upon Laplace transformations comes like this, right? So obviously in this case, again, what you will do, you'll convert the denominator in the form like this, and then we'll write this as a1 by s plus, since see there is nothing, is order of 0, the numerator is order of 0, but denominator is of order 3. So what you have to do, you have to apply some common sense so that the order, the relation between the order can be maintained. What that can be, how can that can be done? By simply putting this as a2s plus a3. So this is the modification that you require so that this order is maintained, and the numerator you can write as a zero order function of s, right? Now we calculate what will be a1. A1 will be simply s fs at s equal to 0. So what will be its value? Oh, not fs, sorry, I'm writing as xs. Its value will be a1 হলটা বলো, ওটা হাফ হয়ে যেত, হাফ। Right? Now you have to calculate a2 and a3. How you can calculate that? For that you can follow your different methods, but what I will follow here is just expand this left hand side. Okay, so if you expand this left hand side, what you will get, a1 into s square plus 2s plus 2 plus a2s, sorry, plus a3 into s, and this should constitute the numerator, and that is nothing but your 1. So if you just simplify this, what you will get, you will get a1 plus a2 s square plus 2a1 plus a3s plus 2a1 is equal to 1. See, I can write this is an identity because this constitutes the numerator of the polynomial, that is 1. So left hand side and right hand side, this is an identity. What are the key equations here? The first equation you can write 2a1 equal to 1, that implies a1 equal to half.
স্যার ওই এস এক্সএস না করে ডাইরেক্টলি এখান থেকে a1 এর ভ্যালুটাও তো বের করে না যেত, মানে একেবারে ইকুয়েশনটা সেট করে কম্পেয়ার করে
করতে পারো, একদম করতে পারো, যেহেতু ওটা একদম ইজিলি একটা ফ্যাক্টরড ফর্মে আছে বলে জাস্ট দেখিয়ে দাও যে দুটো ক্ষেত্রে তুমি একই ভ্যালু পাবে। ওকে, সো ইট ইজ স্যাটিসফাইড, দ্যাট ঠিকই আছে। দেন হোয়াট অ্যাবাউট দ্য আদার ইকুয়েশন? সি হোয়াট ইজ দ্য পাওয়ার অফ এস স্কোয়ার হিয়ার? a1 plus a2. What is the power of s square on the right hand side? 0. So a2 minus a1 that is minus half. Second equation. Then 2a1 plus a3 is also 0. So a3 is equal to minus of 2a1, that is equal to minus 1. Right? So you get your a3, a2 and a1 values like this. So this is another way of finding out this coefficients a1 into a3, right? Other than that particular formula that sxs equal to, at put at s equal to 0 and so on. Because in this case, you cannot put directly that particular formula. You have to, what you have to do, you have to again factorize s square plus 2s plus 2. So rather than that, you can simply have this identity where the numerator is represented first as a combination of this a1, a2, a3 and the denominator polynomials, right? And then comparing the equal powers of s on both sides, that's the coefficient of equal powers of s on the both sides, we obtain this solution. So once s1, a1, a2, a3 is obtained, it's very easy to find out the overall solution, right? So I shall not reiterate the next steps. So let's move on to the next part. That is, when you have, in third case, we have multiple poles or repeated poles. How? Suppose your excess is given as bs by s such that there is some numerator and this as can be represented as s plus p1, s plus p2, up to s plus p n minus r. After that, we have at s equal to pi. So you can say there is a pole at s equal to minus py of multiplicity r. Okay, so what have now how to deal with such factors when you have a factor like this? So what you can do, you can expand excess in the form like k1 s plus p1, k2 s plus p2. Since all these poles are distinct, so you can simply obtain their corresponding partial fraction expansion and this residues can be calculated using the standard formula. So this, up to this far it's okay, because this constitutes n minus r, simple poles, n minus r number of simple poles. The next part will be plus a1 s plus py plus a2 s plus pi square, so on, and ultimately you get ar s plus pi to the power r, and that is r terms of repeated poles at s equal to minus py. So you can calculate this k1, k2 or kn minus r very easily using the residue formula at the respective poles. But this calculation of a1, a2 up to here will not be that straightforward, because see, there the multiplicity of the denominator is increasing, okay, from 1 up to multiplicity of r, right? Then how to obtain this particular coefficients? See, let us move on to the next slide or next page. The partial fraction we want to calculate, the residues that we want to calculate are a1, a2 and ar up to ar. It's taking time to load the next page, just wait. এগুলো তোমরা জানো, কোনো ফর্মুলা জানা আছে ব্যাপারে? So first let us write down the expression a1 s plus pi plus a2 s plus pi square ar s plus pi to the power r. So the formula for ar will be simple formula of residue. Okay, this is followed. But what about for ar minus 1?
সো এবার ডেরিভেটিভ করতে হয়।
Exactly. So it will be dds of s plus, তাহলে জানো তোমরা তাহলে it's the entire derivative. Now this, you calculate the derivative, then you put s equal to minus pi. So ar minus 2 will obviously be standard form 2 factorial of s plus and this entire second derivative then must be replaced by 4 to minus pi. So what will be the final expression for a1 in this pattern? a1 will be 1 by r minus 1 factorial one of same. This all calculated at s equal to minus pi. Right? So let us check, or let us solve an example, small example, just to check whether you are very much conversant with this or not. দেখা যাক এক্সাম্পল দেখা যাক, সেটা হচ্ছে x is equal to 1 upon s plus 1 whole cube s plus 2. So এটার এক্সপেনশনটা কি হবে? পার্শিয়াল ফ্র্যাকশন, এই না, এটা আমি কে দিয়ে বলছিলাম না, k1 by s plus k2 by s plus 2, এটা হলো সিম্পল পোল, প্লাস মাল্টিপল পোল জিনিস কি থাকবে, a1 by s plus 1 a2 by whole square a3 by, right? Now you tell me the values of k1 k2 and the values of a1 a2 a3. বলো, এটা করে বিশ্রাম নেই।
k1 তো s into xs s equals to 0
কত আসবে?
হাফ আসে। k2 কত আসবে? হাফ হবে,
মাইনাস হাফ,
k2 হাফ,
মাইনাস থাকবে,
প্লাস
হাফই তো আছে, প্লাস হাফ।
স্যার হাফই হবে স্যার, মাইনাস
হাফই হবে
মাইনাসটা
তো।
কেটে যাবে।
ব্যাস ঠিক আছে, এগ্রিড। এবার a3 থেকে শুরু করবো আমরা। হোয়াট উইল বি a3?
-1
ঠিক আছে, a2
স্যার 0 আসছে।
আচ্ছা, তোমার 0 হলো, বাকিদের কত আসছে?
0ই আসছে স্যার।
গুড। আর A1টা এখানে লিখছি না, ক্লামজি হয়ে যাবে।
-1।
ঠিক আছে, -1 জিজ্ঞেস করছো না, কনফিডেন্টলি বলছো?
এখানে স্যার তাই তো
স্যার নিচে একটা 2 ফ্যাক্টোরিয়াল থাকবে না, যে -1/2?
না, -1ই হবে।
ও আচ্ছা।
ওপরেও একটা -2 আসছে।
হ্যাঁ স্যার, ওপরে একটা -2 আসছে, নিচে একটা 2 ফ্যাক্টোরিয়াল থাকবে, ওটাকে এটা -1 হয়ে যাবে।
ঠিক আছে, তাহলে বলো আর xt টা কি হবে? হোয়াট উইল বি xt? k1 এর জন্য কি পাবো? k1
1
এই k1 এর হাফ এসছে তো।
হ্যাঁ স্যার, হাফ।
হাফ ইউটি লিখতেও পারো, নাও লিখতে পারো, কোনো অসুবিধা নেই। k2 থেকে কি পাবে?
half e to the power -2
ওকে, প্লাস এবার a1 এর থেকে কি পাবে?
minus e to the power -t
তারপরে a2 থেকে কি পাবে? 0।
স্যার এটা তো 0।
0। তারপর a3 থেকে কি পাবে?
minus না হ্যাঁ minus e to the power -t into t square
তাই তো, সবার তাই পেয়েছো? মানে এটা অবভিয়াসলি এরকমই আসবে, ঠিক আছে। এবার আমরা দুটো প্র্যাকটিক্যাল প্রবলেমে একটু ডিসকাস করে আজকের মতো ছেড়ে দেবো। ছোট ছোট প্রবলেম, এটা তাহলে নেক্সট পেজে চলে যাচ্ছি। হ্যাঁ, নেক্সট টপিকে, দ্যাট উইল বিল্ড আপ টু দ্য নেক্সট ক্লাস। That is, suppose we have a differential equation for a first order system given as where y is the output and ft is your input. Okay, and what is this tau? Tau is nothing but the time constant of the system. Okay, now let us consider the input ft to be ut, that is a standard step input, so that ut equal to 0 for t less than 0, equal to 1 for t greater than equal to 0. Now your objective will to find out the expression for yt, given the initial condition is that the system is initially relaxed. What does that mean? That y0 equal to 0 and y dot 0 is also equal to 0. So find out the expression for yt, given the input is ut.
e to the power minus t for t greater than 0. E to the power minus t for t greater than 0.
Like it?
Sorry, tau included.
না ভাবো করো, একবারে করতে যাও না, একটু ভাবো, কারণ দেখো এখানে জাস্ট বসিয়ে দাও ভ্যালুগুলো।
t বাই টাউ হবে, মানে আমি টাউটা কনসিডার করিনি আগেরটা।
ল্যাপ্লাস নিলে কি হবে? টাও
s y
into
s
sys plus ys equal to
1 by s
1 by s। এখান থেকে তাহলে ys এর এক্সপ্রেশনটা কি আসবে? 1 by s into 1 plus s tau এরকম পাবে। তুমি দেখো যদি একটু ভেঙে লেখো তাহলে এটাকে পার্শিয়াল ফ্র্যাকশন করলে কিভাবে লিখতে পারবে? ys will be equal to say k1 by s plus k2 s plus 1 by tau। ওই যে tau s plus 1 ফর্মে আছে, তোমার এখানে একটা 1 by tau তোমাকে মাল্টিপ্লাই করতে হবে। তাহলে তুমি k1 k2 বের করো। what is your k1? that is s ys at s equal to 0, so this will come out to be 1 and k2 1 by tau টা বেরিয়ে যাবে, 1 by tau টা তোমার কোনো অসুবিধা করবে না, সেটা হবে s plus 1 by tau ys calculated as s equal to minus 1 by tau, so this will be your minus tau. So ultimately what you'll get, your ys will be equal to 1 by s minus tau and 1 by tau will get cancelled out, 1 by s plus tau. So your yt will be equal to 1 minus e to the power minus t by tau. Right? So what is the final value? The final value y infinity will be equal to, using final value theorem, 1. So the response will be something like this. Where should I draw? Is like this essentially, and to settle down to a value of 1, right? So given the step input, you have to go through all the steps, 1 2, then you have to find out k1 k2, then ys, then yt. Now if you change the input to ramp, then again you have to go through all the steps, right? So given another input for which your Laplace transform is given, say ys fs is given, then you have to put that particular value and then you have to calculate that again. So in this way, this process will be a repetitive process if you want to study the behavior of the system or response of the system when subjected to different set of inputs. So in such situations, the repetition of such computation may not always be very much appreciable, because if it is a first order system, that can be carried out very easily without any inconvenience. But if it's a third, fourth, higher order system, and if fs, the Laplace transform of ft, is not a simple function, if it is also a very complex function, then the partial fraction expansion or the extracting the partial fractions may become very difficult. Okay, so in such situations, what you have to do, you have to figure out some method of expressing the output of a system as a function of the input of a system, right? And that gives us the concept of transfer function, right? From this expression of ys, what I can write as ys equal to
স্যার আপনি স্ক্রিনে
GS
কিছু লিখছেন কি?
আসছে না? এবার আসছে?
স্যার এখনো পর্যন্ত তো ওই পুরোনো স্ক্রিনটাই দেখাচ্ছে ডিফারেন্সিয়াল এটা যখন সলভ
এসছে,
করা
এবার
হয়।
এসছে।
এবার দেখো তো,
হ্যাঁ এবার এসছে,
কোনায়
এবার
লিখেছি
এবার
হ্যাঁ,
y
এসছে,
GS
এবার
এবার
এসছে।
এসছে।
হ্যাঁ এবার এসছে স্যার।
একটু ডিলে আছে, ভালোই ডিলে আছে। দেখতে পাচ্ছি ইকুয়েশনটা y GS into US।
হ্যাঁ স্যার এবার দেখতে পাচ্ছি টপ রাইট
হুম
কর্নারে।
হুম হুম। হ্যাঁ হ্যাঁ হ্যাঁ, রাইট, ওই একটা ডিলে আছে। তার মানে this GS will represent the transfer function, and this transfer function will give you an initial expression, not initial, the instant expression of output in Laplace domain. Okay, so you don't have to solve the differential equation repeatedly for different sets of inputs. Rather, what you can do, you can have the expression of ys directly if you have the knowledge of us, and from that expression of ys you can obviously infer about the nature of response by looking at the roots of the characteristics equation that will be the roots of this GS. That is called the poles of GS. By looking at the poles of GS, you can have an idea about the response of the system. So obviously this YS will have two responses. One, the roots coming out of GS, that is called the unforced response or the natural response. And one of the roots that will be contributed by US or the input function, that is called your forced function or the forced response. Okay, so using transfer function, you can obtain this response of a system, which is a combination of the natural response of the system and the forced response of a system, right? So in this way, you can obtain the response of a system just by multiplying the input in the Laplace domain to the transfer function in Laplace domain. So this concept of transfer function will help to study the response of a system under various input conditions very easily. I have a initial idea about the response. Okay, whether it is stable or unstable, whether the poles are in the left up plane or right up plane, whether it's underdamped, overdamped, or critically damped, depending upon the location of poles in the left up plane. So in the next class, we shall discuss about the concept of transfer function, the application of transfer function, and the pros and cons of transfer function. Right? So in the meantime, I'll give you a simple assignment. এটা এখানে থাক. Okay, next class we'll again discuss about transfer function. I'll give you a simple assignment for all of you. So what you have to do, you have to solve the assignment, and I'll provide you with a link in the classroom for the Google form where you have to take a screenshot of your answer and submit. Okay. It's taking a lot of time to load the next page. Okay. The assignment will be something like this. Find initial value of dft dt for fs equal to 2s plus 1 divided by s square plus s plus 1. So the problem statement is that given fs 2s plus 1 divided by s square plus s plus 1, you have to find out the initial value of dft dt. Right?
ওকে স্যার।
Okay. Now I'll give you a simple another problem. Okay. Just for the sake of your understanding, this will be a second order system given by the differential equation y double dot t plus 3yt y dot t plus 2ut equal to 5 ut. This ut is a unit step function, obviously, with the initial conditions right. So these are the two. So you have to submit before the next class. Okay.
স্যার
So
তাহলে
deadline. বলো বলো।
হ্যাঁ স্যার, তাহলে আপনি আর ক্লাসরুমে কোনো কোয়েশ্চেন দেবেন না, এই দুটো কোয়েশ্চেনই করতে হবে তো?
হ্যাঁ, এদেরই করতে হবে। আমি তোমার ক্লাসরুমে কি তোমরা অ্যাক্সেস করতে পারছো সবাই? মনে হচ্ছে না।
স্যার পাচ্ছি আমরা তো, যারা পাচ্ছে না তার মানে হোয়াটসঅ্যাপে শেয়ার করে দেওয়া হয় যদি মানে কোনো নোটিফিকেশন
ওকে
আসে।
ওকে, আমি তাহলে গুগল ফর্ম একটা ক্রিয়েট করব। ওকে, গুগল ফর্ম ক্রিয়েট করে ক্লাসরুমে দিয়ে দেবো। যারা পাবে তারা বাকিদের ওই ফর্মের লিঙ্কটা শেয়ার করে দেবে। ওই ফর্মেই তোমরা ফিল আপ করে জাস্ট ছবিটা এই প্রবলেম দুটো করে ছবি তুলে একটা সিঙ্গেল পিডিএফ ফাইলে দেবে। হ্যাঁ, দুটো মিলে একটা সিঙ্গেল পিডিএফ ফাইলে কনভার্ট করে দিয়ে দেবে।
ওকে স্যার।
ইউ ক্যান ইউজ অ্যাডব স্ক্যানার। ওকে, অ্যাডব স্ক্যানার ইউজ করলে পিডিএফ ফাইল হয়ে যায় সিঙ্গেল পিডিএফ ফাইলে। বাট জাস্ট কিপ ইন মাইন্ড যেন পেজিং গুলো পরপর থাকে আর পেজের ওরিয়েন্টেশন যেন স্মুথ হয়। মানে একটা ল্যান্ডস্কেপ মোডে একটা পোর্ট্রেট মোডে ঘুরি ঘুরি দেখতে হবে এরকম যেন না হয়। ওকে
ওকে স্যার।
এভাবে অ্যাসাইনমেন্ট গুলো তাহলে করে দাও। দুটো সিম্পল প্রবলেম দেওয়া আছে। আর এখানে একটা জিনিস বের করবে, given yt you need to find out the steady state value of y infinity, the steady state value of the response. ঠিক আছে, তাহলে 8/4 মানে ক্লাস শুরু হওয়ার আগে যেন অ্যাসাইনমেন্ট গুলো সব চলে আসে। ইনফ্যাক্ট 8/4 না, আমাকে তো দেখতে সময় দিতে হবে। তোমরা আছো অনেকজন না, প্রায় 100-র ওপর। একটু এগিয়ে দিই। আজকে তো 1 মানডের মধ্যে করে দাও। ঠিক আছে, ওকে
স্যার এরপর থেকে কি সব ক্লাসই এরকম 4:30 PM থেকে শুরু হবে?
হ্যাঁ, ইনফ্যাক্ট এটা বেটার আমার জন্য। ঠিক আছে, দুটো ক্লাসই তোমাদের সিগন্যাল সিস্টেম এন্ড সিকোয়েন্সিয়াল সিস্টেম। হ্যাঁ, আমি ধরে নাও 4ও হতে পারে। তোমাদের কি 4:30 আগে কোনো ক্লাস থাকে মঙ্গলবার কিংবা বৃহস্পতিবার?
থাকে স্যার, মেশিনের ক্লাস থাকে 4:30 থেকে, কোনো অসুবিধা নেই।
কোনো অসুবিধা নেই তো, তাহলে 4:30 থেকে শুরু করবো। ঠিক আছে, কারণ আমার সন্ধ্যাবেলা কি আবার ক্লাস আছে একটা, এটার পর একটা ক্লাসে থেকে খুব তাড়াতাড়ি হয়ে যায়। সো 4:30 ইজ ফাইন। এই ধরো 4:30 বলে দেখো শুরু হতে 4:45 হয়ে যায়, তাই না? সুতরাং সেই টাইমটা আমাকে নিতেই হয়। সুতরাং সেই জন্য 4:30 ধরবো, 6:15 সেরকম সময় ছেড়ে দেবো। ঠিক আছে,
ঠিক আছে স্যার।
স্যার আরেকটা জিনিস ছিল একটু বলার।
হ্যাঁ বলো বলো বলো।
স্যার বলছি কাইন্ডলি আজকে যেই ক্লাসের রেকর্ডিংটা একটু শেয়ার করে দেবেন একটু।
হ্যাঁ হ্যাঁ, আমি শেয়ার করে দেবো। আগের দিন বলার সঙ্গে সঙ্গে করে দিচ্ছি। আজকেও ওটা আসতে আমার কাছে দেরি হয় একটু, মিনিট 10-15 কি আধ ঘন্টা মতো লাগে।
ওকে
এলে আমি ক্লাসরুমে শেয়ার করে দেবো।
ওকে স্যার, ওকে স্যার, তাহলে মানে এটা প্রেফার করে। ওকে, থ্যাংক ইউ স্যার।
ঠিক আছে ঠিক আছে। ওকে, আই এম ড্রপিং দ্য কল নাও।
ওকে স্যার।